Now we're going to look specifically at right triangles and their sides, and we can find lengths of sides by using the Pythagorean theorem, which is a squared plus b squared equals c squared. In order to use that theorem, we have to know what a, b, and c are or represent. And so we're going to be looking at right triangles and calculating missing sides. The longest side of a right triangle is the hypotenuse, and the other two sides are considered to be the legs. And then if c squared equals a, then c is a square of a. So the first thing we have to do is look at square roots, because we're going to be dealing with those in this lesson. A square is a number times itself to get 36. So what times itself is 36? And perfect squares are numbers that you're probably familiar with, but we just haven't worked with them a lot. So the square root of 36 is 6, because 6 times 6 is 36. The square root of 144 is 12. The square root of 1,600, well, the square root of 16 is 4. So the square root of 1,600 is 40. And if you're not sure, you can use the square root button in your calculator and it will calculate them for you. The square root of 400 would be 20. And the square root of 441 is 21. So now, what happens if they're not perfect squares? Then we do approximations, and it looks like a squiggly equal sign. And if I want the square root of 13, I'm going to have to use my calculator, and I get approximately 3 decimal places, so 606. So if you're going to do approximately, use a squiggly equal sign and then round it to the decimal place. So the square root of 31, and I can guesstimate, I know it's going to be between 5 and 6, because the square root of 25 and the square root of 36, 25 and 36 are my perfect squares. 31 falls in between that, so I know it has to be between 5 and 6, and it's 5.568. and so on. So you can just use the square root key in your calculator to find that. Now, how does that apply to our Pythagorean theorem and our triangles? Find the length of the third side, give an exact answer, and an approximation. So they want us to do both. Well, first of all, let's go through and label everything. So these two sides, the two sides that make up your right angle, are your legs. And the longest side of your triangle is the hypotenuse. Now, when you're working with the Pythagorean theorem, one of your legs you can call A, and the other one you can call B. The hypotenuse is always C. So when we have A squared plus B squared equals C squared, and we go to put in our values, I would have 8 squared and 6 squared, because those are my legs, is going to equal the square of my hypotenuse. And you could have labeled the legs, you could have said 6 was A and 8 was B. It doesn't matter. So when I square 8, 8 times 8 is 64. 6 squared is 36. And when I add 64 and 36, I get 100. But 100 is not my answer. The hypotenuse is not 100 inches long or whatever. 100 equals c squared. So what we have to do to find just plain c is find the square root of 100. And the square root of 100 is 10. And that's our missing side or hypotenuse. So what actually happens here when I'm solving equations? How do you undo a squaring? Well, that's the square root. So what we actually did was we had to take the square root of c squared, which is c, and the square root of 100, And that's how we ended up with c equals 10. Now on these problems, they don't give you a picture, they just describe what it would look like, so I highly recommend that you draw your own picture. So let's look at this first one. I'm just going to draw a right triangle. They're telling me A is 5 and C is 13, and so I'm finding B. Well, remember your theorem is A squared plus B squared equals C squared. A squared, that's 5 squared, plus we don't know B, but C is 13. So this is 25, and this is 169. And now I have to start solving. So I have to subtract 25 from both sides. That's going to leave me with b squared equals, looks like 144. So now I have to take the square root of both sides. Square root of b squared is b, and the square root of 144 is 12. So it looks like 12 is my missing side. So 5 and 12 are my legs, and 13 is my hypotenuse.